Today, we are diving deep into one of the most grueling, back-breaking jobs in the entire supply chain. And we're going to meet the incredible AI-powered robot born out of MIT that's finally figured out how to tame it. So before we get to the machine itself, just picture it for a second. Think about a giant warehouse, right? Millions of packages moving around every single day. What do you think is the one job that's the absolute hardest to automate? The one that still needs pure, raw human muscle? It's this. It's what they call the wall of chaos. Imagine a truck trailer packed floor to ceiling with boxes. No pallets, zero organization. Everything's just jammed in there and it's all shifted and gotten crushed during the trip. It's a three-dimensional puzzle from hell, and it has absolutely stumped automation efforts for decades. Well, until now. And here is the solution. This is the Pickle Robot. It was designed from the ground up for one very specific, very messy job: to autonomously stare down that wall of chaos and take it apart one box at a time. Now, you look at it, and the arm and the wheels are pretty cool, for sure. But the real magic, the absolute game changer, is inside its brain. It's running on a concept that the company has coined physical AI, and it lets the robot see and actually understand a jumbled mess of boxes in a way that's, well, it's almost human. So, what in the world is physical AI? Okay, you know about AI, like ChatGPT, right? That stuff lives in the world of words and data. Physical AI is a whole different animal. It's built for the real physical world. It takes the incredible pattern-spotting power of generative AI, mixes it with machine vision and real-time decision-making, and lets the robot see, predict, and actually do things to the objects around it. And this is basically how its brain works. It's in this constant loop. First, it senses the scene. It uses its cameras and LiDAR to build a 3D map of that wall of boxes. Then it plans. And it runs through thousands of possible ways to grab a box in a fraction of a second. Then it acts. But here's the brilliant part. If it tries to grab a box and fails, it doesn't just freeze. It senses the failure, instantly replans based on the new situation, and tries again. It learns from its mistakes in real time. You know, the best analogy I've heard for this is that it's like playing a massive, high-stakes game of Jenga. The AI isn't just looking for the easiest box on top. No, it's calculating which box it can pull out without causing the whole stack to collapse. And it's running those calculations thousands and thousands of times every second to find the perfect move. Of course, having a genius-level AI brain is completely useless if you don't have a body that can actually carry out its orders. So let's take a look at the hardware, the nuts and bolts that bring all this intelligence to life right there on the loading dock. So the whole system is built around this incredibly durable KUKA industrial arm. These things are workhorses. That arm is mounted on this tough, rugged mobile base that literally drives itself right into the trailer. But maybe the most important piece of all is the part that actually makes contact with the packages, and that's the gripper. And that gripper really is Pickle's secret sauce. You see, normal suction cups, they're terrible. They fail all the time on beat-up cardboard or boxes with tape on them. So Pickle went and developed their own custom pneumatic suction head. It creates this high-flow system that can latch onto almost anything, from shrink-wrapped packages to heavy, porous boxes. And this thing is seriously strong. We're talking about a lifting capacity of over 65 pounds. Now that covers a huge, huge percentage of all the stuff that's moving through a warehouse on any given day. This is real heavy lifting, done over and over and over, all shift long. Okay, so we've got the brains and we've got the brawn. But the big question is, how does it all come together in the real world? How does it actually perform? Let's check out the numbers, because this is where the business case really starts to take shape. The number everybody in logistics cares about is picks per hour, or pph. The Pickle robot can hit a max speed of 1,600 pph. Now, a really fast human worker might be able to match that for, 10, 15 minutes? But the robot? The robot can maintain that pace for an entire 8-hour shift. No breaks, no fatigue, no injuries. And this is where the economics just go to a whole new level. This isn't about one robot replacing one human. It's about making humans way more productive. A single supervisor can manage an entire fleet of up to 5 of these robots. They just handle the weird 1 in a million problems, while the machines do all the repetitive, dangerous, backbreaking work. So how does Pickle really stack up against everyone else? If you look at this chart, you can kind of see its unique place in the world. A manual system, obviously, relies on human hands.
Boston Dynamics robot Stretch is all about its incredible mobility, but Pickle's sweet spot, its whole reason for existing, is its physical AI. It's built specifically for those messy, chaotic, unpredictable trailers that other systems just can't handle. Okay, so the tech is clearly powerful. It's here. But what's the plan for getting it out into thousands of warehouses? And let's be honest, what can it do yet? Let's talk about the business strategy and some of the real-world limitations.
So Pickle is way past the science project phase. They're already working with absolute giants like UPS and Usin Logistics. They just landed a $50 million funding round, and they're rolling these out using a robots-as-a-service model. That just means warehouses don't have to buy the robot outright. They basically rent it. It makes it way, way easier for companies to adopt the technology. But hey, it's not perfect. Not yet. The robot needs a little bit of elbow room on the dock to get itself set up. And those super extreme edge cases, like a huge chemical spill or boxes that are literally frozen together, that's still a job for a human. And unlike a person who can just jump in, the robot does need a brief moment to get itself aligned and calibrated for each new trailer. And all of this brings us to the final and most critical question of all. When you factor everything in, the robot's incredible consistency, the fact that one person can supervise 5 machines, the huge reduction in workplace injuries, how quickly does that robots-as-a-service fee get erased by the skyrocketing cost and unreliability of manual labor in a warehouse that runs 24/7? That's the math that every single logistics manager in the world is doing right now.